Okay, so we are in our first week, and the question we want to ask in this week is, what does a test score actually mean? What does a test score actually mean? So we are trying to move from the classical test theory to item response theory, right? So I'm assuming that I'm not making any assumption as per the level of anyone for this class. All right. So we are coming to the grassroots, to the basic level. Also, is also a way to remind us, all right, to remember what we have previously done. So in our first class, I was giving an example. I said, what happens if in a test two students got the same score? Who are we going to judge to be the better student? We know that from the word classical test theory, this test theory is a theory that has been very helpful, in developing a lot of tests, especially non-reference tests, right? Now, I want to give this scenario. If we arrange assuming we give a test and we have like 10 students in the class, and then we arrange their scores in ascending order from the highest to the lowest. Assuming the highest person scored 90 and the next person scored 80. Yeah, okay. I just want to record so that for those who are not um, part of this session, they can be able to go back to it. I know we have the note, but also for record purposes, you could still go back to it. I hope that is fine. And also it will also be important to maybe the master's degree group as well. So it's just for us to have something we can fall back to. I hope that's fine. I know that
It's okay, sir.
we are running out of time, but
It's okay. Go on, sir.
okay. So uh, so if we are to arrange those scores in ascending order, we know that the first person scored 90, second person scored 80. The 90 is going to occupy the first position, the 80 is going to occupy second position. Now, assuming the next two, highest position is occupied by two students, let's say 65 over 100, we are going to add the two positions and divide by two to find their positions. So that's going to be the third position plus the fourth position divided by 2. And that's going to be 3.5th position for the two persons. So under the classical test theory framework, we assume that if students have the same score, they have the same ability. So the classical test theory framework looks at the student ability in terms of their overall score. And that takes us to the equation for it. X is equal to true score plus the error component. All right, so the score which the student got in the test is not the true score, is the observed score. So the true score would be the average score the student would get if you add up the many times they attempt that same question, provided all conditions remain constant. And then the error component are the testing factor, the testing factor psychological factor, might be tired, might have worries and all that. Guess, and then we have the test factor, which is it could be that the test, the script is not clear enough. The wordings, the instruction, there are no clear instruction on what the student should do, and so on and so forth. And then we have the environmental factor, which is the classroom could be noisy. Um, the hall might be hot and all that. There might be the lighting might be very poor, and the student might find it difficult to read through the script. So all these are the error components. So for classical test theory, we know it's very, very useful in the reliability analysis, determining reliability. And reliability has to do with the extent to which a measurement instrument measures what it purports or ought to measure. So, and the reliability is judged in terms of a coefficient. So, the coefficient that ranges between 0 and 1. So, under the classical test theory framework, there are two methods we use in determining reliability. The first is test retest, and the second is Cronbach alpha method. So for test retest, we know what it is. You administer the test twice. You just give probably 2 weeks interval in between, and then the both set of test scores are correlated. So whereas in Cronbach alpha, the test is administered once, and then the idea is just to find out, how well the items cluster, which of the items, how well they cluster together. So basically, based on the range tells us if our test is reliable or not. So we go to the item statistics, which we also call the psychometric properties. So for CTT, we are interested in item difficulty, which is called p-value or the b-value. And then we are also interested in item discrimination or point biserial correlation, which is also called the A parameter, right? So for item difficulty, we are talking about how many students got the item correctly, all right? So how many students got each of the items? So assuming for item 1, first question, we have 80 students that got it. So the 80 means that the p-value or b-value or item difficulty for that question is 0.80 and so on and so forth. And then for item discrimination, we are looking at how well the test is how much the test is able to distinguish between those who are knowledgeable and those who are not knowledgeable. So we have a range, although this range usually varies. For item difficulty or p-value, the range from 0.90 to 1, very easy items. So in this case, we know that the items are too easy. So it means that 90%, more than 90% of students got the items correctly. So it's very easy, and it means that we can make use of that item. So the next range is 0.7 to 0.89. So it means that more than 70% of students got the question right. Well, that question is easy. Might probably require, it might be a good question to, provide so that those who are not too knowledgeable can at least, pass, get those right. And then the next one is student question that a student is able to, about 40% of the students or more is able to get it right. So this is where we create the spread in the score, all right? This is the right range. So we expect that this is the right range where we expect that for a test item, at least 40% of students should be, if 40% can be able to get it right, so it's a good benchmark. And then we have the hard, which is 20% or more, between 20% to 39%. Then we accept that it's a difficult question, and then less than 19%, and so on and so forth. So there are different ranges also for discrimination. All right, so now we go back to why CTT is not enough. Why is CTT not enough? CTT, the first reason is sample dependence. So CTT depends on the sample. All right, so the ability level of the student who take the CTT will determine, that take the test will determine the difficulty level of the the test. So if that test is given to students that are knowledgeable, it means that difficulty level might go down a little bit. All right, but if it's administered to students who are not knowledgeable, the question might appear to be difficult. So one of the problems with CTT is that it depends on the group of students that you administer the test to. The next one is the score error relationship. So in CTT, there is a general assumption that the error is constant for every score. All right. So every score that is produced for each student, the standard error is the same. And we know why that is the case. It's the case because of the cumulative nature of the CTT. CTT looking at the scores all together, like the overall score. So since you have overall score, you end up also working out the overall error, which is the SEM, right? So the SEM is the same for all the scores. So that's one of the problem. And the next problem is item level focus. CTT focuses on the total test score. So we've been talking about this, focuses on the entire test score. It does not look at the individual items. It looks at the overall performance. So that is a problem with CTT. Now let's go into IROT. Let's go into IROT. Now, IROT asks a different question. It doesn't ask the question, unlike CTT that asks the question, what is the student's overall score? IROT asks, what is the probability that a student with a certain ability will answer a particular question correctly? So CTT is concerned about the response of the student to each item of the question, irrespective of their overall ability. So a student that is very brilliant can still fail an item that appears to be easy. So IROT focuses on the certain ability on that part, on the individual items. All right, so and that would take us to what we call the item characteristics curve. This is a very important concept in IROT, the item characteristics curve. And the item characteristics curve, it looks like this. All right. The item characteristics curve looks like this. You can see the B is our difficulty index. The A is our discrimination index. This is a two-parameter logistic model. All right. And this theta is the testee's ability level. So you can see that in item characteristics curve, it ties the probability to the student's ability, which is theta. All right, so probability is tied to the student's ability. So an item characteristics curve, you can see how it's like it's half of a normal curve. So if I cut my normal curve into two, this is what the item characteristics curve is. So this x-axis is the continuum, all right, is the ability level on the continuum, all right. So students within this range, right here in the middle, are average performing students. Now we remember from our statistics that even from the idea of a normal curve that majority of students would fall, right in the average section. So you see that this is our item characteristics curve, and this is a probability of providing correct response. All right, this is probability of providing correct response. So the thing about the item characteristics curve is that, I'm running out of time. So yeah, we just have 40 minutes. So for item characteristics curve, at the probability of exactly 0.50, if I move my theta to, we can see that the probability, if I reduce my theta, you see that my probability, my p here is reducing. So the higher the ability, the higher the ability of the student, the higher the probability of them getting the question correctly. You can see that the probability is moving towards 1, which is which is perfect. So we are going to go into our practice. So for the practice, we are making use of arrow. So we'll use the next 10 minutes to practice. It's a very short practice session. So we should be able to make use of the next few minutes of our time to do this. So you should be able to install your arrow. So these packages are very important. I'll come to that much later, but let's go straight to the practice. So for our practice, you need to install your arrow. This is my arrow. This is my arrow package. So the arrow package has 4 interfaces. The first interface is the console. All right, the console is where the result of what you are running is going to display. So this is the console panel. This is where whatever you run your commands here, this is where the result is going to, show. The next interface is your source interface. So this is where you input your arrow command. The next interface is the environment interface. This is where you upload your file. It could be in .csv format. You upload it here. And this section is the section where you can install your files, install your arrow packages. All right. For example, in this practice work we have, you need to have your psych loaded. Now, how do we load our psych? You go over to, it's already loaded, but how do we load it? We go here. We are going to call the package. All right, here we are going to type. This is where we have our library. All right, this is our library. The library has all the packages that we need. Now you can see in my library, I have psych, I have psychometric, I have hemp, and I have validate arrow. Now, but for this class, I need the psych and the MIROT. So my psych is there, but I don't have MIROT, so I'll have to install it. Go to install, I'll click MIROT, and then I will install. I need the psych package and I need MIROT to be able to perform this task. So I'm going to, so whatever package you want to install in Arrow, you have to come over here, click on the package, all right? Click on your package, install, and you search for the package, and then you install it. I think we have less than 5 minutes. Okay, we have a new message. How do we get there? Okay, have you installed the Arrow package? Or you have to install the Arrow package.
Yes,
I think we can
I've
still fix
installed
a
it.
class. Let's fix a class that 8 o'clock. Let's fix a class at 8 o'clock on Friday.
Okay,
I will try to be
8 o'clock.
punctual, okay? So that we
Right.
can try and install the packages because some persons might be finding it difficult to
Okay,
install
physical
the
class.
Arrow package. So I hope we can fix the
Okay,
class
thank you.
that 8 o'clock and we can secure that
All right.
the hall for this purpose. My challenge with the class is that we might not be able to make use of projector. If we can have where we can use projector, it would have been very much easy. So, or if there's a way somebody can, if we can borrow projector, probably we can go to the department and I think the department has a projector. So if we can sort that out, then it will be easier. But although the recording session helps to have something to fall back on, that is just my idea of recording. So I will come to how we go about how we got here in the physical class, but this is just for record purpose, okay? So that you can still come back and see what we've done. So there are two packages that we need to be able to run this. Is the psych package and the MIRT package. You can see that I have the psych package. Probably having a network issue because you need your internet to be able to install these packages. The thing about Arrow is that Arrow can have 1,000 of files here. All right, so it depends on what you are working with, what you want to work on. Okay, whatever you are trying to analyze will determine the package that you will need. So, and then that will determine the one that you are going to require. Now, let's just start with the one we have. We have the psych package. There are two ways you can call your package. In R, we call it to call the package. All right. There are two ways. Either I come to package here and I tick it. All right. You call it so that it will become responsive. Otherwise, it's dormant. So let me close my arrow and restart it again. I don't know why it is okay. I don't know why it's slow today. Okay, I think it's installing. Let me just restart. Oh, I have just 1 minute to wrap up. Okay.
Hold on, I'm still around.
And the thing about R is that you must make sure that your system is functioning very well. Very, very important. That your system is not slow. If it is slow, it is also going to be it will not respond the way you want it to respond. So make sure you have enough memory, enough space in your system. Make sure you don't have too many things loaded on your system. Okay, so we are back now. Okay, so this is the environment. These are the 4 environments I've come to. So as I said, you go to package here. I think this is my code. I pasted my code. But before this code can run, I have to awaken these packages. You have to awaken them because they are almost like in a sleep mode. You have to put them to action before this can be able to run. Otherwise, we cannot be able to run this. Okay. So here I'm going to click on MIRT. I don't have it. It does not exist in my library. So I'm going to